Welcome back. Still on factors affecting preferential discharge of ions during electrolysis. We have explained position of the ions, how it affects how ions migrate. But this can only happen when there are two competing ions. Maybe when you have two similar ions and they are competing to which ion that will be discharged. And that's where the position will play a very vital role. And the set rule is that the lower the ion, the ease of discharge. Just like in the electrolysis of copper 2 tetraoxosulfate 6 or copper 2 sulfates. Okay, the ions that you see in that solution, in that electrolyte, are copper 2, hydrogen ion from H2O, sulfate ion from the acid, and then hydrogen ion from the acid. So you're going to see that copper 2 will compete with what? Hydrogen ion from water. I would know. The H plus will come because both are similar, both are cations. So during that competition, one is preferentially selected for discharge, and the one that is selected for discharge is the lower of them all. So that is where copper 2 is discharged and not what? Hydrogen. It means that hydrogen, for the time being, remains in the electrolyte as copper is being what? Discharged. Then look at the two electrodes, just like we have explained earlier, that the electrode that is negative electrode is the cathode. Okay? And at the cathode, cations migrate. Okay? So it means that hydrogen and copper 2 will migrate. But in terms of discharged, one is preferentially selected for discharge based on the position. And what is the position? The lower the ion. It appears that copper is lower than what? Hydrogen in the what? Electrochemical what? Series. And then copper being the one discharged. As it's being discharged, it's going to leave the solution, okay, to the electrode. But on getting to the electrode, copper will gain an electron to reduce, because one chemical process that happens at the cathode is reduction, and reduction is the what? Is the what? Gain of electron. So copper ion is going to gain electron from the electrode, from the cathode, then reduce before it's discharged, before it is added to the electrode. So that is going to increase the mass of that cathode. So what happens after which is that the cathode will what? Increase in size. Are you with me now? And then remember that at that same point, hydrogen is still in the electrolytes. Then at the anode, because this process is redox, because as the cathode reaction is going on, the anode reaction is also going on. So you have now cathodic half cell reaction as well as what? Anadoic. So coming to the anode now, there are two ions that are to compete at this point, which is the OH from water, okay, and then the sulfates from that salt, from that ionic salt. So if you now check which one will go before the other, it appears that OH migrates and not SO4. So in this case, SO4 will remain in the electrolytes, which now combines, because they're going to have positive and negative ions in the electrolyte. They will both combine to form what? H2SO4. So one can even say this, that in this process, tetraoxosulfate 6 is produced in that process. This is an industrial preparation of H2SO4. Apart from getting it from dissolving acid anhydride in water, one can even electrolytically manufacture H2SO4 using electrolysis of copper 2 tetraoxosulfate 6. But in that case, electrode use must be inert. I'm still going to discuss using a reactive electrode in that same salt. But for the fact that the electrode is not reactive, it is not, the ions are not going to be interfered with the electrode. So there will be ease of migration. So at anode, OH migrates This is where it's going to oxidize. By what? By giving out its electron to the anode. And then oxidize to liberate what? Oxygen what? Gas. So the product made at the anode in the electrolysis of copper 2 tetraoxosulfates using either platinum or graphite is what? Oxygen gas. So it appears that at that anode, you're going to see a lot of bubbles to show that gas is what? Evolved at the what? Anode. As the electrolyte is now acidic, because the electrolyte now has it to, the electrolyte now is what? Tetraoxosulfate what? 6. That is on position of the ion. But what about when the ion, one of the ion is concentrated? That's what we'll talk about, concentration of ion in the electrolytes. That's another factor that can affect how ions are discharged. This also has to do with when you have two competing ions. Let's say electrolysis of aqueous sodium chloride and dilute sulfuric acid, aqueous sodium chloride. Now, when you have something that is salts, sodium chloride, okay, plus solvents, I have less of the solid. This is going to be solid, okay, and then water. You now have more of the water. What do you say about this, having more of this than this? You now say that this is what? Diluted what? NaCl. Are you with me now? So in that regard, this is going to split into Na what? Plus and Cl what? Minus. And this is also going to split into what? H plus and OH what? Minus. So these two migrate to what? To cathode. Of course, you should expect these two to migrate to the what? Anode. So now, between this and this, which one goes in preference? Between H plus and sodium, because two of them cannot go at the same time. That's why we have position. Hydrogen goes in preference, yes. So if hydrogen goes in preference now, it then means hydrogen cannot go with this charge. Is it going to gain electron at that cathode or lose the electron at the anode? It's going to gain, isn't it? Because it more reduced. So it gains that electron and gets itself reduced. All combined hydrogen does not exist anywhere. It doesn't exist. So it ought to be H plus what? H. Have what? H2. So you can conclude by saying instead of H, I can say that means 2H plus gains 2 electrons to form what? H2. So if you go to the cathode of that reaction, there will be bubbles showing that hydrogen gas is evolved. So the product at the anode, the product at the cathode is hydrogen gas. Are you with me? Then, on the other hand, this and this migrates. Are you with me now? So this and this migrate. So between these two ions, they can't go at the same time. So which one is preferred? OH minus, isn't it? So if OH is discharged, of course, OH discharge is going to split to give me what? O what? 2 and what? H2 what? O. So what you see at the anode is what? Evolution of what? Bubbles or what? Gas. That is what the product form is what? Oxygen gas. And let's look at the electrolyte after this had happened. On electrolytes, we have your anode and your cathode, and you have your electrolyte here. Remember that H plus goes and then sodium remains. Are you with me now? Sodium remains. So when this goes, it goes there and what? Gain electron. Okay? Before reducing to hydrogen gas. So you're going to see bubbles here. Bubbles. So this is where you see hydrogen gas here. At the same time, OH minus goes in preference to what? Cl what? Minus. So it goes and liberates bubbles, which means here is oxygen gas. Here is what? Hydrogen gas. Then what is the nature of the electrolyte? The nature of the electrolyte remains the same because the electrolyte was NaCl and the end is still NaCl. It remains the same, but concentration increase or decrease? Increase. because there's no water. Because it has more of water at the beginning, but at the end, there is no water. So it means that you have more NaCl than H2O. So the concentration increases. But the electrolyte remains what? The same. It does not what? Change. But what if you have more of this and less of this? What do you have here now? You have what? Concentrated. This is where you now call it electrolysis of what? Brine. That's why I say brine is a concentrated solution of aqueous sodium chloride. Are you with me now? There is as little. Oh, it may be water that it comes with naturally. Can be molten. Okay, so this is what it is. At this point, I'm still going to have the same ion. Okay, the same ion, the same ion. But this is where concentration now had to play its own role. Concentration of the ion. It appears that the more concentration an ion is, the ease of what? Discharge. In most cases now, concentration overtakes position of the what? Ions. But there must be condition for concentration to overtake. It does appear that at this point now, Na plus is more concentrated than what? H plus. So during deposition now, it may appear that sodium ion will be discharged and not hydrogen ion. And at the anode, that this will be discharged and not this. But like I said, there must be condition for concentration to overtake position of the ion. This can only happen if the ions are close to each other in the what? Series. Basically, if you look at that position of ions, most likely cations. So the position of sodium to hydrogen is very, very distant. In as much as sodium is more concentrated than hydrogen. But because of the distance, both ions are very far from each other. I mean now, hydrogen is now discharged, even though sodium is more concentrated. So in that case, nothing changed. Hydrogen is what? Discharged. So the product at the cathode is still hydrogen what? Gas. But at the anode, if you look at the ions at the anode, you see the charges you likely see at the anode appears to be this, and this. I think iodine should be somewhere, I don't know. Okay, no, iodine should be here. I, then what? O minus. If you look at the portion of Cl, look at the portion of what? OH. It appears that the ions appears to be much closer compared to sodium and what? Hydrogen. So one criteria is this: the ions must be what? Close. So in this case, chloride ion will overtake what? OH ion. So what is discharged in this case is not this, but what? This, chlorine. So that means at anode, which products is formed at the anode, that anode? Which products form? Chlorine what? Gas. This is one method used to what? To prepare chlorine industrially. Apart from laboratory preparation. In the lab, we prepare chlorine by oxidizing HCl using a powerful oxidizing agent like what? Manganese oxide or potassium permanganates. This is the lab. That will give us a very minute quantity of chlorine. But in the industrial scale, you can prepare chlorine in large scale using what? Electrolysis of what? Brine. Are you with me? But you know, in this, it's very expensive. No laboratory can do this. What you must know. So those that make chlorine, and chlorine is very, very, very important chemical substance because chlorine is used as a what? Bleaching what? Agent. And the chlorine can also be used in the manufacture of what? Hydrochloric what? Acid. So it's very important chemical substance. That is in large scale. Electrolysis of what? Brine. This describes electrolysis of what? Brine. So it can apply electrolysis to what? To industrially manufacture what? Chlorine. A powerful bleaching what? Agent. Remember, chlorine can only bleach in the presence of what? Oxygen. So you must You must react chlorine in water before it acts as oxidizing what? Agent by bleaching using its oxidation. So now at the end, if chlorine is discharged in the electrolysis of conc NaCl, that means OH had to be in the electrolyte. Chlorine that goes here is collected and then used for bleaching and also to synthesize HCl. And in that regard, the electrolyte appears to be what? NaO what? H. So it means that sodium hydroxide can also be manufactured industrially by what? Electrolysis of what? Brine. Electrolysis of brine. And sodium hydroxide has so many uses. So many industrial uses. One of the important uses of sodium hydroxide is that it is used in the manufacture of what? Soap. You can't talk about soap without this. Soap. Soap. So this no method you can get this. Soap. Use it to make soap. It can also be used in the extraction of, in the purification of bauxites. We want to remove impurities from bauxite. We want to remove iron oxide, sand from bauxite. Dissolve that all using this. So it can also be used to purify what? Bauxite. You can also use it in acid-base what? Titration. This one, current uses of this. So you can get it from what? Electrolysis of what? Conc NaCl. So it's very, very important. Know this. Very important. Know this. So let's say when electrolyzed, aqueous sodium chloride, it produces bubbles of gas at both, I think I told you, at both electrodes, as chlorine and hydrogen are produced, leaving behind sodium hydroxide. That is in electrolysis of what? Brine, when it is concentrated. That is not when it is diluted. Same thing goes with dilute sulfuric acid. Sulfuric acid there is tetraoxosulfate what? 6. Okay, if you do that, sulfuric acid, electrolysis of dilute sulfuric acid will give you hydrogen goes to the cathode. You make hydrogen gas in that process. So you can produce hydrogen gas on a large scale using what? Electrolysis of what? Dilute HCl. Sorry, dilute what? H2SO4. Where product produced at the cathode is hydrogen. Then product at the anode is what? Oxygen. The hydrogen made at the cathode, you can just get it and use it to make what? Margarine. Margarine. I think you know what? How margarine is synthesized. That is hydrogenation of what? Oil or fat and oil or vegetable oil. Always give you what? Margarine. These are what we call uses or applications of electrolysis. Okay, aqueous sodium chloride. Chlorine is used to make bleach. Hydrogen is used to make what? Margarine. Sodium hydroxide is used to make what? Soap and detergent.